So one of the reactions that I miss the most doing this lab virtually rather than in person is the Grignard reaction. It's one of my favorites. I spent a lot of time in graduate school doing Grignard reactions, so you might think that kind of would ruin the reaction for me, but because I have a lot of experience dealing with the very finicky aspects of the Grignard reaction, I kind of have learned to love it. So a Grignard reaction is when you create an organometallic compound from an alkyl or aryl halide. In this case, we're starting with bromobenzene. An organometallic compound contains organic parts and a metal part. In this case, we're adding the magnesium in between the benzene ring and the bromine. So an organomagnesium bromide. That is a Grignard reagent. So they're useful in a couple of different reactions, but the most common one is to use that material as a nucleophile to attack a ketone, aldehyde, or other carbonyl compound. In this reaction, we're reacting with benzophenone to create triphenylmethanol. Now, one of the aspects of Grignard reactions that makes it so finicky is the sensitivity to water. The sensitivity to water comes from the fact that the Grignard reagent is such a strong base. It will grab a proton off of a lot of things, and it's very easy to grab a proton off of water. And if you have any moisture on your reaction flask or in the atmosphere, it's going to protonate that Grignard compound, and then your reaction's not going to work. So if you look through the experimental procedure, there's two things that you can do. We do the flame drying. You can also put your glassware in the oven overnight, and that's what I would often do when I do this in graduate school. Flame drying is faster. You can do that in the moment, and you get rid of most, if not all, of the moisture that is attached to the flasks and the other parts of your equipment. So you create the Grignard, you initiate when you start mixing the aryl halide and the magnesium, and you create a very cloudy grayish brown mixture. Once that is formed, you add in your benzophenone solution, and it goes through a lot of color changes there, which you can see on your lab materials. And you create an adduct, which is a salt. So it's an alkoxide salt. And so, like a lot of other reactions that happen in organic chemistry, you have to quench the product in order to make it neutral. In this case, we have to add acid in order to get it to a neutral alcohol, and then you extract it. So the product material triphenylmethanol is not very interesting from an NMR standpoint. It contains a lot of aromatic protons that are very similar to each other. But the IR is very distinctive because you go from the ketone, which has a very specific absorption, as we've looked at in spectroscopy problems. The absorption for the ketone goes to an alcohol, so those are very different, and that's what you look for in the difference between the starting materials and the product. So make sure you look at all the material that we've provided, including the pictures we've provided of students doing the experiment in lab, in order to see all of the changes that you would for the Grignard reaction.